my name is Simon Redding. I'm a product manager at Guidewire, and I'm focused on simplifying integrations between InsuranceSuite and our third-party ecosystem. So today I'm joined by Mark Bolger, who is our lead integration developer for Guidewire Cloud. And today we're going to be talking about downstream integration, simplifying outbound integrations from InsuranceSuite to external systems. So this is a super common integration pattern in which you have an external system which needs to be notified that something has happened in InsuranceSuite. And it needs to do this in order to be able to keep the external system either up to date or to trigger automated actions as a result of workflow and transactions that have occurred inside InsuranceSuite. So this is a very common pattern. You can imagine things like fraud scoring, med-bill review, estimatics, outbound payments. All of these incur some kind of outbound integration. So in the past, this kind of event-driven integration was implemented using event messaging, which works very well. However, it does require Gosu coding. And today we're going to be introducing application events, which allows us to have a no-code and low-code approach to doing this kind of event-driven integration. So we have the obligatory slide. Plans can and do change. So bear that in mind when we're talking about future product direction. So let's take a quick look at the agenda. So basically, we're going to start off by talking about integrations, what makes them hard in P&C, and what can we do about it to make it simpler in Guidewire Cloud. Then we're going to do a deeper dive into outbound integration in particular. Then I'm going to share with you a demo of application events using Webhook for delivery of the events. Then Mark is going to talk to you about using Integration Gateway to deliver events to allow you to talk to additional kinds of systems. Then he's going to jump in and discuss how application events internals work, kind of the under-the-hood view. Then we're going to talk a little bit on release timelines, and then get into some Q&A. All right, so integration, regardless of industry, is complicated, and that's doubly so with P&C. So what is actually driving that complexity? So with an InsuranceSuite implementation, there are many integrations that are involved with the core system. So you can imagine there could easily be 100 integrations that are involved, right? And each of these systems is different, right? They have different workflows. They're not necessarily designed to work together. They might use different protocols, different file formats, and so on. So there's a lot of integrations. There's a large degree of complexity and a large degree of variability as well. So the question is, how do we really manage this and make it a tractable thing? So I'm sure over the last few days you've seen this slide. I'm just going to recap this. So our approach to simplifying integrations in Guidewire Cloud involves a number of different frameworks. Okay? So the first framework is the InsuranceSuite Cloud API. And what this API is, it's a fine-grained API, productized API, which allows you to do business actions in InsuranceSuite. So this is for inbound integration, where the flow is triggered from the external system. Okay. Then the next, which is the one we're going to be focusing on today, is called application events. So this is a new feature, and what it allows us to do is to publish events to a downstream system, and to do this in near real time. Okay? Finally, we're going to talk a little bit about Integration Gateway. So what Integration Gateway does is this is effectively Apache Camel, which has been seamlessly integrated into Guidewire Cloud. And what it does is it allows you to build integration applications which bridge between InsuranceSuite and the downstream system. And Mark's going to talk about some of the capabilities when he gets into that. So, all right, so outbound integrations, this is the focus of what we're talking today. So just to make sure we're on the same page, I'm going to go through this. So the scenario here is you are having work that is being performed in InsuranceSuite. And this could be users doing work, like adjusters, underwriters, and so on. Or it could be triggered by an API or some kind of process. But the point is, business transactions are getting committed in InsuranceSuite. And then you have downstream systems, and they need to know what is going on. Why do they need to know? Basically, they often need to keep their data in sync with what is happening in the system of record. Or it might be the case that you want to be able to trigger an action in the downstream system as a result of work that occurred in InsuranceSuite. So this is a very common pattern, and typically the way that this is addressed is using kind of an event-driven design. So by an event, I just want to make sure we're really clear about this. So an event encapsulates that something occurred in the core system. So an event has a name, for example, exposure opened, and it is associated with an entity in the InsuranceSuite data model. Okay? So the general flow is work getting done, transactions getting committed, and then what happens is InsuranceSuite uses this mechanism called event messaging in order to raise events. And these events could be data-oriented events, so you could think of these as like CRUD-like events, creating things, updating things, and so on, adding reserves, documents being added, that kind of thing. Or they could be more policy lifecycle events or claim lifecycle events. So for example, when a policy is bound or renewed or canceled. These are all examples of events. So, and there is the event itself, and then there is the related data, the context for what was going on at the time of the event. So this is how traditionally event messaging has worked in InsuranceSuite. So if you read this left to right, you can see what the data flow is. So here we have the transactions happen in InsuranceSuite, events fire, and then there is some logic which is encapsulated by customer-written event fired rules. And what these rules do is they look at the event and they work out, do I need to send a message to a downstream system as a result of this event? And if the answer is yes, then these event fire rules then have to create a message, a payload that has all the related data which explains what the event is and gives additional context. So that could be additional information about the claim, the policy, the account, and so on. Okay, so events have fired, the event rules have determined that some message needs to be sent to a downstream system, and the message is being composed, it's being queued up for delivery, and then it needs to get from InsuranceSuite to the downstream system. So how does that happen? So this is achieved through message transport plugins. So again, these are like customer-written plugins, and what they do is they pick up the event and they transport it to the downstream system. And that could be over JMS, it could be making a SOAP call, it could be creating a file. There's a lot of different options there. Okay? And then ultimately, the event will get to the downstream system. So it could be the Medbill review system or whatever, which will see this event and it will respond accordingly, whether it's updating itself or triggering some kind of action. So today I want to talk to you about application events. So, I mean, what are we trying to achieve with application events? So what we're doing is we're trying to move from something which requires custom GoSu coding in the core to actually externalizing this and moving more towards no code, low code, integration code externalized outside of InsuranceSuite. And these events are going to be delivered in near real time to the downstream system. And a key point about this is we're trying to reduce the amount of custom GoSu integration code that is part of InsuranceSuite. And the reason for this is that when your integration code is part of InsuranceSuite, if you want to change your integration, it's going to interfere and impact the other things that are going on, because the business logic and the integration logic, it's all mixed together in one place. So by using techniques like app events and integration gateway, it allows us to externalize this code, move it into outside of InsuranceSuite, so that you're able to update that code, update the integration code semi-independently from the business logic, which is happening in that. So this is a really huge win, because if you think about it, it allows your teams to work a little bit more independently, so it creates greater agility when your business team, which is focused on building the functionality, can work independently of the integration team that's focused on the plumbing. Okay. So another goal with this is we really had performance and scalability in mind. So what we did was we built this on top of cloud-native technologies, and we're also using Apache Kafka as well. So the reasons why we're using these technologies is because it gives us a lot of options for like scaling and so on. So what is App Events? So basically, App Events publishes InsuranceSuite events and related claim or policy information to the downstream system in near real time, okay? So the event, that could be something like the claim opened, a submission-related event, and so on. And then the related data, what I'm talking about here is a snapshot of the entire claim or a snapshot of the policy or the account and so on, okay? So we want to be able to publish this in near real time. And we have two delivery mechanisms for this, for different use cases. So one of the mechanisms uses webhooks. How many people are familiar with webhooks? You raise hands if you are. Okay, so a bunch of you. So with the webhook approach, this is something that you would typically use if you're integrating with a pretty flexible system, which is able to expose a custom HTTP endpoint. And then what would happen with this delivery method is when an event is fired, it's going to get delivered over HTTP to the downstream system. Effectively, it's going to post the event to the custom endpoint that you've exposed in that system. And it's not only going to have the event name and metadata about the event, it's also going to have the claim or the policy information as of the time that that occurred. Okay, so this being able to generate early bound payloads in an efficient manner is really important, and this was something that we really focused on when we were building this feature. Okay, so that was the webhook approach, but application events, I mean, often you're integrating with a system that may not be that flexible. It might be that you can't expose an HTTP endpoint, so what do you do then? Well, this is where Integration Gateway comes in. And as I mentioned earlier, Integration Gateway's real strength is that it's able to mediate between different protocols. So it has lots of different clients for talking in different protocols, and it can do transformations, it can do orchestration of integration logic. So this gives you a lot of flexibility in the delivery. Because what it means is that if you're talking to a system that's SOAP-based or file-based, you can still use the application events to trigger the flow. It's just that you're able to do a lot of transformation before you actually do the delivery. So this pretty much means you can talk to any system on the outbound. So this is the webhook case. So this is the codeless case. And I just wanted to show the data flow through this. So you can imagine an adjuster performs a task in Claim Center, maybe they file a claim. And this is going to generate events, claim opened, contacts added, assignments being made, and so on. Each of those events is going to have data. The data is going to be the full claim graph. So what I mean by the claim graph is the claim and all related information. So incidents, exposures, parties involved, the policy snapshot, and so on. So this is a two-step process, right? So these events occur, and as an intermediate step, we actually publish them outside of the InsuranceSuite into Apache Kafka. So the events go into a Kafka topic. And we maintain a snapshot store of the related claim or policy information. And then we have a set of services which are then going to pick up these events and deliver them to the external systems using the subscription information which was defined through a UI. So you're going to see this in a minute in the demo. But the point of a subscription is a subscription will be defined for each of your integrations, and it says this integration cares about these events, and it wants to send them to this destination, and it's going to post these events to a particular web address that has been exposed by that downstream system. Okay. So now we're going to see a demo of this in action. This is about 3 minutes long. So it should give you a really good idea of how the webhook delivery mechanism works. And then after this, Mark's going to talk to you about the integration gateway delivery. Okay.
Now I'm going to demo event delivery to a downstream system using App Event webhooks. In this demo, a developer sets up a subscription to publish events to a test system on the internet. Then an adjuster creates a claim in Claim Center which will fire app events. Finally, the developer is going to view the logs on the test system to see what events were delivered and what they look like. For the test system, I will use a website called webhook.site. This allows us to expose a webhook on a unique URL. Our subscription will publish our app event data to this URL. The website also has a viewer where we can inspect the data sent to the webhook. We will use this viewer to see what events have been sent and what the events look like. You can see that no events have been sent yet. Now the developer will set up the subscription. From Guidewire Cloud Home, I launch App Event Webhooks. Here we can see a list of subscriptions which are being configured. Each subscription is a claim or policy event feed that is published to a downstream system. Let's drill down to a subscription called Medical Bill Review Feed. A subscription has a number of elements. Star System and Planet identify the InsuranceSuite environment that will publish the events. The app field indicates whether we are interested in Claim Center or Policy Center events. In this case, we want Claim Center events. Then we can choose the events that the downstream system should receive. Claim Center has a large list of events, and we can choose from this list. We can also define a custom event. In this case, we've chosen Claim Opened and Exposure Open events. Then we specify the endpoint which will receive the events. We have entered the URL of the webhook exposed by the test system. Now that we have configured a subscription, we can start to use it. Now an adjuster goes into Claim Center and creates a claim, entering the basic information, the loss details, requesting services, and finally finishing the claim. Now we have a complete claim file and a set of application events have been fired. Now the integration developer looks at the event viewer for the test endpoint. We can see 3 events have been delivered for the subscription, corresponding to the Claim Open event and 2 Exposure Open events. Let's have a look at the structure. An event has a header and a body. The header has metadata about the event. The body contains the event payload. In this case, the serialized claim. App events are structured to conform to the Cloud Event spec. This allows them to be processed by middleware. The Cloud Event headers begin with CE as part of the HTTP headers. The type indicates this is a Claim Open event. The source indicates the InsuranceSuite cloud environment that generated the event. The primary object ID is a unique identifier for the claim in Claim Center. There are also event and transaction IDs. An event signature allows a downstream system to verify that the event truly originated from the source system and has not been tampered with. Moving on to the event body. Here we can see the snapshot of a claim. This includes loss details, all the related incidents, exposures, and so on. The claim graph format is the same as that used by the Guidewire Cloud APIs, which are used for inbound integration. Note that the claim snapshot is early bound. This means that it is accurate as of the time that the event occurred. This is important for many integrations, especially those including financials. So to summarize, we configured an event feed, we performed work in Claim Center, and we saw the events published to the downstream system. This was all set up through a configuration UI without requiring any Gosu coding.
What Simon just showed was webhooks. This is the way you can get app events data out of the system via HTTP and JSON. But as Simon alluded to earlier, you're often dealing with systems that aren't flexible enough to accept that. Or it may be the case that you simply want to trigger a set of actions or an integration flow off of the event, not just export the data. This is where Integration Gateway comes in. So just like webhooks has a direct, easy connection to app events, Integration Gateway does as well. It receives all of the events that app events publishes. It receives the data along with them, and then allows you to easily pass that data off to integration routes if you're making. They can manipulate that data and forward it on to other systems. Being built on Apache Camel, there's a wide variety of possibility here. It supports many different kinds of APIs, uses different security models. You can do transformations, maybe data format to data format, or even in shape and size. You can also change the pattern itself. Maybe you use the event and some contextual data to trigger a notification or some other happening in another system. The way this works is again, just like webhooks. Claim Center is producing the events. The app events system is post-processing them and preparing them for the integrations. We have a custom app events component in the Apache Camel nomenclature, which receives those events. It provides a bit of default filtering. So like Simon was able to select the events he cared about from the UI, you can pick the events in your component that you want. It can even do additional filtering, like maybe removing claims that are still draft. We don't care about events on draft claims or policies that aren't yet bound. It then hands it off, any events that make it through that filtering, to your integration route where you manipulate them as you want. You hand them to an outbound component, and that makes its way to another system. To dive just a little bit further in here, I'm going to show you actual Apache Camel code. So starting on line 15, we have our from statement in a route. This means the data is coming from this URI. The URI's protocol is app events, specifically addressed from CC or Claim Center. We give it an ID and we tell it that we care about the claim opened event. Maybe you care about more than one, you can add a list. And you can also add those additional filters, such as ampersand filter draft claims equals true. We then process the message. It's important to note here that Apache Camel has an abstraction of message for all of these routes. Wherever the data came from, wherever it's going, it's in the form of a message. And so an event, in our case, the body of the message is the data that we saw from the demo, and the headers are headers on the message. Here I select, or I get the body as a JSON document. I select a particular field on line 18, and then I write it as a header, which I might need for my other system. On to the next step on line 21, I marshal the entire body of the message to JSON, and I send it off to a JMS queue called opened.claims. Now, of course, in a real scenario, there would be a lot more configuration, the security and location of that JMS system, but the actual integration functionality is captured here. Things like marshaling, connections to other systems are not things that you deal with. You use the integration gateway, or rather Apache Camel componentry to do that. So whether you are connecting to some system that simply needs another protocol for that data export, or you want to have a more complicated using the event as context and trigger for an integration, you can do it in Integration Gateway. So to recap, Webhooks is the no-code option. All of the events come out as JSON HTTP, and any system that can stand up an endpoint will receive them. This is great for publishing data to other systems, possibly collecting it there or using it in that system for integration work. An integration gateway is a low-code. We saw the DSL just there. It's a low-code option, but it has flexibility to deliver that data over different protocols or even change what we're going to do with the event and the data around it. So with that, I want to talk about how it actually works. Because many of you will be familiar with event messaging, what this is meant to replace. And so it's good to see exactly what we are providing above and beyond what event messaging does today. At a very high level, App Events is a stream processing pipeline between InsuranceSuite and the consumer. As you saw, consumers always receive an entire snapshot of the data. And you can also guess that IS cannot reasonably be creating this entire snapshot at every transaction in the system. And that is what the App Events system is for. To start at the very beginning, there is actually a new messaging destination inside of Claim Center or Policy Center. And the job of this destination is to collect all of the existing events via event fired rules and produce data for them for our other system. It listens to all ORM events, and every ORM event is attached to an entity. It takes that entity, maybe claim, exposure, incident, and it looks up the view of that entity in the cloud APIs. So whatever integration view is attached to that entity, it will make use of. And just a quick note, if you're not familiar with integration views, they are a successor to GX models. They are the combination of a schema and a mapping, which produces a model in our case of JSON, off of an entity and various mappings. So you can see here an exposure was added, and we have exposure data along with it, and then an exposure was updated, and we have exposure data along with it. In our case, it went from open to closed. That's the only difference. But key here is it's only exposure data. If the exposure's changed, we receive exposure data. Of course, this is not what we saw Simon showing. This is not what the downstream consumers show. Before I dive into how we end up with the full payload, I want to point out technology again. Apache Kafka is what we're using. Our partitioning scheme maintains safe ordering guaranteed by event messaging. So we use claim ID or account ID and policy for our partition keys. This ensures that while we can operate at scale and process many claims at the same time, we will process a particular claim's set of events strictly in order, and you will receive them strictly in order as well. So from here, we reach a system that we've called the app event processor. And the app event processor's job is fairly simple on the surface. It receives these data updates from InsuranceSuite. It uses a state storage engine to store snapshots of that claim. It does that by looking up the previous snapshot, applying the update, and then storing the new snapshot. It then propagates the events downstream where consumers can receive them and then look up the snapshot for their own use. Again, it's doing this constantly, parallelized across many claims. To dive a little deeper on tech again, of course, I mentioned the first topic is Kafka. The second one is as well. We maintain partition keys, again, maintaining that safe ordering from InsuranceSuite all the way to the consumer. The storage engine we've built on top of the combination of Dynamo and S3. We've done this because Dynamo has size limits and S3 does not, at least not similar size. So we can handle large documents, but we have the advantage of latency that we get from Dynamo. This thing can work very fast. So consumers like Integration Gateway, webhooks, or even our internal services, which want to kick off these same events as well, are hitting our snapshot storage, DynamoDB, in order to drive other processes, not putting load on InsuranceSuite. So I want to walk through an example then here at the end, looking at the actual data, and I'll walk you through. So back to the first slide we had, Claim Center has produced two changes, an exposure added and an exposure updated event. We can see that the exposure added was the exposure 50. It was against claim 1, and in this case, the data was of state open, and in the exposure updated example, it's on the same claim, same exposure, but it is now closed. The processor takes the added event. It reads the last. So in this case, we are looking up the last version of claim 1. We apply that update. Now, applying that update is a little less straightforward than it may sound. Notice that there is a header I haven't explained yet. It's called path. This tells us where the changed data belongs in the entire schema. So in claim, the updated data is at the path exposures where the ID is 50. Of course, an added event, this is going to be new. So our processor inserts this exposure at that spot. It then writes the new version of claim 1 and propagates the exposure added event downstream. The exposure updated comes in. We see the exact same process occurring. It looks up claim 1. It applies the update to exposure 50 in place. It then propagates the exposure updated downstream. Now, in a real running system, there's not one event per transaction. There are many, many. They can be a fairly large number of events. And semantically, when one transaction has many events, they all happen simultaneously. Our processor and our snapshot storage do not store intermediate state. So the granularity of every claim is true to the time the event occurred, even though many events occur at the exact same time. So you can see this in the downstream system. The references are to the snapshots database, the particular claim, and the transaction ID for the claim that we care about. Simon mentioned how downstream systems, maybe in the form of financials, it's very important that these are early bound. If something is added and removed in quick succession, it will be captured during the first transaction state of that claim, and then it will be gone in the second. But integrations have an opportunity to react to both of those things in time. They do not lose the visibility of something added and removed. And that's it. This downstream topic is what Webhooks plugs into. It's what Integration Gateway plug into. Both of them use Apache Kafka directly in order to maintain that safe ordering still. And they all, or both of those two systems, go to our snapshot storage engine for you before sending the data either to your route or to your system via HTTP.
Thanks, Mark. So now I'm going to talk a little bit about the release timeline for these frameworks. So currently, application events and integration gateway are in early access. And then in the spring, in the Elysian release, we're expecting them to go generally available. So what this means is that when something is in early access, we limit the number of customers that are able to uptake it at once. So that limit will be removed once we move to Elysian. So one thing I wanted to point out is that with integration gateway, that is something that will just be enabled. And it's kind of agnostic as to which of the InsuranceSuite applications you're using. Whereas with application events, we need to enable application events on a per InsuranceSuite application basis, which is why I've listed out claims and policies separately, because they involve separate work. Oh, I should also mention that we have the Cloud API, which is for our inbound integrations. So this has been generally available for a long time, and this is what's used to trigger for inbound integrations, triggering different business transactions in InsuranceSuite. And with each release, we're adding new APIs to expose new functionality through the API interface. So, all right, so what happens next? So to preempt a question, this is not available on self-managed. The reason for this is that for the reasons I talked about earlier around the scalability and so on, we're building this using the facilities that are provided by Guidewire Cloud Platform. Okay, so if you're on self-managed and you want to use this, you would need to migrate to the cloud platform first. If you're already on GWCP, Guidewire Cloud Platform, and you're interested in using one of the integration frameworks for one of your integrations, then you should talk to your CSM about leveraging the frameworks and getting it part of the early access program. If you're one of our partners who's interested in using the new frameworks, you should talk to your alliances manager and express interest so we can start you getting set up. All right, well, thanks very much for joining, and drop us a line if you want to learn more.